Hi guys, it's another video. I wanted to do a couple of the harder questions in the application section. So this is 1K. I've copied this out of the textbook. This is question 8. So a question containing ducks and sheep. There's a paddock. There's a total of 42 heads and 96 feet in the paddock. How many ducks and how many sheep are in the paddock? Okay, so thinking, let me just hang on a bit. Okay, so let's start by defining our variables. We're trying to find out how many ducks and sheep there are. So let's say D equals number of ducks, and obviously S is going to be number of sheep. Okay, so we're also told that there's 42 heads and there's 96 feet. Okay, so let's do one equation for heads, and we'll do another equation for feet. Okay, so we know the number of ducks. All ducks have one head. Okay, so and so do sheep. So the number of heads is going to be the number of ducks plus the number of sheep. They both have one head, so the number of ducks' heads plus the number of sheep's heads is going to equal 42. Okay, so feet's a different story because ducks have 2 feet and sheep have 4 feet. Okay, so it's the number of ducks times 2 plus the number of sheep times 4. Okay, so that's going to equal 96. Okay, so let's, we should be able to, can we eliminate? Not quite, because we're going to have to, what we're going to have to do here is change one of this to the lowest common multiple. Okay, so I'm going to look at this ducks here. Okay, so this D. Alright, now you don't necessarily have to times both equations. This is the example where if I call this equation 1, and I call this equation 2, to get this to a situation where I can eliminate, I just need to get this to 2. So I have to times this by 2. Okay, I times this equation by 2. Alright, that's going to give me, and I'm just going to write it directly under. Okay, I'm going to times this whole equation by 2. I get 2D plus 2S equals 42 times 2 is 84. I'm going to call that equation 3. Okay, so I've got 2 equations now, so this becomes the heads equation. Okay, I've just popped it under because it actually doesn't matter where we take what we take away from what. In this case, 2D take away 2D is going to cancel out. 4S take away 2S is going to equal 2S, and 96 take away 84 is going to equal 12. So let's write that down. That's 2S equals 12. So what that tells us is that the number of sheep is equal to 6. Okay, so if the number of sheep is equal to 6, we sub back into equation 1, and we get our equation D plus 6 equals 42. Solving that, we get minus 6 from both sides. D equals 36. Okay, so that's the number of ducks and sheep. Okay. I've got another question here. This is question 9. So another bit more challenging one. So you always start by trying to define your variables. Okay, so the question asks how many 10-cent coins does he have. Okay, so number of 10-cent coins is going to be one of our variables. Now this is a bit of a problem because 10 cent, we can't call the variable 10. What we're going to call our variables is going to be 5 and 10-cent coins. What will we call them? So it's up to you. You can use X and Y. I'm going to call 5 cents. I'm going to call that variable V because it's Roman numerals for 5. And I'm going to call this 10 cent. I'm going to call this X because that's Roman numerals for 10. Okay, so a couple of things we know. Let's start down writing out what we know. We know that he has $10 in total in his change jar. Okay, so he counts 157 in total. So what that says is, so this is out the number of coins. It's okay. That's what the variables are. So we can say that V plus X is equal to 157. All right, we know how many in total there is. Okay, so we also know a value amount. All right, so let's set up another equation. So the number of 5-cent coins, now this is going to be tricky as well because the end result is in dollars and the value of these coins is in cents. So let's work in cents. Alright, so 5 cents is going to be 5 times however many there is, plus 10 times however many 10 cents there is. Okay, and that's going to equal $10. Now in cents, that's going to be 1,000. Okay, we've got to work in the same units. Alright, so let's work that through. We've got two equations with the same variables in them. Alright, again, we've got this single here. Now I'm gonna use substitution to do this. I'm going to show you how to do that. Because we can really easily manipulate this question or this equation to make v or x the subject. Okay, I'm going to make v the subject because I just have to times 5 by v. So we're going to get my calculator out. So I'm going to change this around. To get v as a subject, I'm going to minus x from both sides. So my new equation will be v equals 157 minus x. Okay, I could have used elimination to use this. I just thought they're all elimination method. Let's use a substitution. Okay, so now we have a value for x, and I'm going to substitute back into this here. So this v goes back in here. Alright, so what I do now is I get 5. Now in brackets, 157, I'm going to need my calculator, plus 10x equals 1,000. Okay, now I have to expand this. That's 785. I use my calculator to do that, by the way. Plus 10x equals 1,000. I've got some like terms now. Minus 5 or negative 5x plus 10x is plus positive 5x equals 1,000. I'm going to take away 785 from both sides, and I get 5x equals 1,000 minus 785. So that's 215. Okay, divided by 5, divided by 5, x is equal to 43. Okay, so that's one of my answers. That's how many 10-cent coins is in the question, or in the jar. So if you have a look at the original question, how many 10-cent coins does he have? You've got your answer there, 43. Okay, so no need to work out the 5 cents, although you could do it quite easily. Okay, that's all for now. I'll just leave that there. That's all for now. Like and subscribe.